Okay, let's begin. So I hope you had a nice morning in the sunshine. So first question from Hayden is, in our first test, will we have a cheat sheet? So the short answer is, in the first test, it is no notes from you, no handwritten notes, and no calculator. Okay, we have to do one test with those conditions, and it's best to do it in the first test. What that means is for every subsequent test, so the next 5 tests after our first one, you'll have 1 page of handwritten notes and your calculator. So that being said, I'm not providing you with handwritten notes, but you will have a copy of the summary sheet on the back. So you will have the unit circle, you will have all of the rules that we're going to learn. So you can see, if you're just reading down it, we've got first principles, we've got the simple differentiation rules. Yesterday we did chain rule, today we're doing product rule. You can see there's a number more that we're going to learn. But you will have them provided, you just won't be able to take handwritten examples into the test with you. There's also the logarithmic laws there for collecting logarithms. Okay, so today we're doing the product rule, and this is going to be a nice, short, sharp, shiny one. This is a reasonably straightforward skill. And then later in the lesson, perhaps when we get back from recess, I would love to address from yesterday, chain rule, question 5 and 6. They are some challenging problems. So, the product rule, like its name suggests, product is another word for multiplication, right? And if we have some function that can be written as a product of 2 functions, we have one function multiplied by another, okay? Like here's an example, we have 5x multiplied by 2x take 3. They're both functions because they both have some variable x within them. So if y is u times v, then dy on dx, the derivative of our function, is going to be u dash v plus uv dash. That's our rule. So with this one, okay, we're going to start off pretty easy. With this one, the first, if you were to solve this using methods you've learned yesterday and in the past, you would go, right, I can't differentiate that, I need to expand it. I need to expand it, and then I can differentiate it. So we could do that. If you were to expand this, you'd get 10x squared, take 15x. Okay, that's still the function. And then you can go f dash of x is now 20x, take 15. Okay, so you can get the derivative in this question by expanding it. The reason we're learning this rule is because later when we learn derivatives of e and ln and so forth, we're going to have to use the product rule. So we do it first with some simple ones, and then when we learn some other more complex ones, that's when we've got the rule. We understand the product rule, so we can apply it. So that would be one way we can do it, right? What we want to do today is use the product rule. So we need to identify, what are the 2 functions that are being multiplied here? Well, this is u, this is our first function. U is 5x, and v is 2x take 3. All right, we've got u and we've got v. Good choice of letters, right? They look pretty similar, u and v. So my v's, I'm going to be trying to be very deliberate and have a real point at the end. Okay, and then we can have, well, u dash just means the derivative of u with regards to x, right? U dash, what's the derivative of 5x? 5. What's the derivative of 2x take 3? 2. All right, and then we just mash it together. It is u dash v plus u v dash. So u dash v, now let's be very clear, f dash of x equals. The notation they've used is f of x, so we have to use f dash of x. U dash v plus u v dash. All right, and that's fine. You get full marks there, right? Differentiate without simplifying. This is probably a 2, possibly a 3-mark question. All right, you've demonstrated how you're applying the product rule, and here's the solution. If we wanted to simplify it, we can, all right, by expanding and collecting like terms. 10x plus 10x, 20x, take 15, okay? Now looking at these processes, obviously this one's a lot shorter, okay? This one's a lot shorter, and it will be now, but we're going to do some more complex ones where it won't necessarily be the case, all right? So, product rules, identify u and v, and then u dash v plus uv dash. Okay, let's move on to the next one. So they're going to start off nice and clear, which one's u, which one's v. So if we have a look up here, u is always our first function, x to the 3. V is our second function. We've got the cubed root of x, take 5x. So I'm going to write it like that now. U dash is going to be 3x squared. V dash we can't do straight away because we need to express everything as a power of n. So I'm just going to write, well, hang on, this is still v. It's x to the third, take 5x. And now we can write, what is the derivative of v? What is v dash? 1 on 3, x to the minus 2/3. Take 5. Okay, so we've used y this time, so that means for our answer, it's going to be dy and dx. U dash v, 3x squared multiplied by x to the third, take 5x, u dash v plus u v dash. Alright, and we'll leave our answer like that. Looks like a pretty messy one to expand and collect and so forth. Okay, u dash v plus u v dash. Okay, so that's all well and good. But as we're going to see in the next problem, the complexity is just going to keep increasing. It's going to get more and more complex. Now, one question you might have about this one is like, okay, that's u. Why is that whole thing v? Alright, so here's the simple answer. It's because what we have is we have x to the 3 multiplied by that whole thing. That's what those brackets mean. If you were to expand it, you would need to distribute it to both terms. It's this one multiplied by this one. Okay, so here we go. On to the next one. U, I'm going to write them in a list this time. So u is x squared and u dash is going to be 2x. V is 2x, take 5x to the half to the power of 3. Alright, so already in my initial statement, I've converted it straight away to x to the half. That means it's going to save us a bit of ink, it means we don't need to write it again. Alright, but now for v dash, we need to use the chain rule. We need to use what we did yesterday. And so we have this complex derivative that involves first using the product rule, but in order to apply the product rule, we have to use the chain rule. So this is great, it gives us an opportunity to refresh it. Chain rule says if we have some function to the power of n, then the derivative is n times the function to n take 1 multiplied by the derivative of the function. Okay, that's the chain rule. And so we're just going to apply the chain rule right here. We can see we've got a function to the power of n. So then the derivative of that function is going to be n multiplied by the function to the power of n take 1. That's the first part of it. But then that is, so n f of x, n take 1, multiplied by the derivative of the function. So then you just look at the inside, what do I get when I differentiate this? We're going to get 2, take 5 on 2, x to the minus half. Alright, 5 times a half gives you the 5 on 2, and we bring that half out front. So, like, we spent all of yesterday's lesson learning that skill. And now I'm applying that skill in like one step. I'm showing you how. We've got the product rule u dash v, and to get v dash, we have to use the chain rule. And there will be questions like that that combine the rules together. Okay, so then we're ready to make a statement about what the derivative is. I'm going to start here because it's going to be a massive long one. Alright, pencil that off. dy and dx equals u dash v. plus u v dash. Alright, so you can see what a clunky mess that is. So we definitely won't simplify that one. Very good. So in the exercise today, just grab your book here, thanks Miller. Most of them are just, pretty straightforward, find the product rule. But then with some of the later ones, it's good because we get the show that. Starts with the function and it says show that the derivative is this. So that does require that sort of algebraic manipulation. So let's get cracking on this exercise. We'll get a good 25 minutes in before recess. And then when we come back, we can talk about 5 and 6 together from the last lesson.